Okay, as we go on now to part 3 of chapter 7, we're moving into the topic of adding or subtracting rational expressions. When we multiplied or divided, we didn't care what our denominators were, but when you add fractions, in order to have it equal in a sense, you have to have equivalent fractions whose denominators are the same. So, keeping that in mind, we're going to move on. Now here our denominator is the same, and what I want to try to show you is a strategy for doing these. Common denominator will be 17, and then now we just add our numerators. So when you are adding fractions whose denominators are already the same, you just put your numerators as a sum over your common denominator. So our common denominator here will be 4n. We have 13 plus 11 will give us 24m. And in a sense that's correct, but you notice you now can do some factoring, canceling out. Take a 2 out of there is going to, or actually you could take a 4 out of there. That will be a 1, and a 4 out of there is 6. So now your final answer will be 6m over n. All right, going on to number 3. Again, our common denominator is going to be y minus 8. And what I'm trying to show you again is a way to do it that you could perhaps be helpful to you. Now here we have a negative, so I can make this a plus and put the negative up there. So now this becomes 5y minus 40. But notice now from the previous section we could factor out a 5 out of there. And I get y minus 8 times 5. So now we have a common factor, and my final answer will just be 5. Now, again, common denominator is x squared. Well, actually what I'm going to do, since I know something can be factored out of there, is I'm going to factor this. That's my common denominator. So I factored this into that. That's my common denominator. Going to change this to plus, put the negative there. So I now have x minus 8. And now these cancel out. And my final answer is 1 over x plus 6. Let me tell you that sometimes what students do is they will write this answer as x plus 6. And then of course that's incorrect. The 1 is in the numerator. X plus 6 is in the denominator. It's a fraction. If you just write it as x plus 6 in an answer column somewhere, that's wrong. As we continue in section 3 of chapter 7, Again, we're adding or subtracting rational expressions, but the item they want us to work on first is to find the least common denominator, the LCD. And they're giving us two terms to work with. So what we're going to do with these two terms is show you the strategy for finding the LCD. So basically what we do is we factor what we have here. So this is going to be a 5, and this is a 3 times 5. And then here we have y to the 7th, and this is y. So the least common denominator of our numbers, we need to have all of these factors, will be 15. And we need to take the highest exponent on our variable. So in this case, it would be y to the 7th. So we're trying to find the lowest common denominator of these two terms. We don't really care what's in the numerator. We want to find the lowest common denominator. And it would include every factor of what we have there. So this one was sort of easy. This one a little more challenging. So again, factor this. So we take out a 9, and we get x minus 2. And here we're going to take out a 3, and we get x squared minus 4x plus 4. Now if you notice, this is a perfect square trinomial that will factor into x and then minus 2 minus 2. So they're asking us what would the least common denominator be for these two terms. Well, keep in mind that this 9 is a 3 times 3. So we would need a 9 that would take care of this one. We need actually 2 of these. So this would be, between these two terms, our least common denominator. Again, this is a skill you'll be working on, and now we're going to actually use it. So I thought we were going to go into the actual addition and subtraction, but they're going to give us a little more practice. And what they're asking us to do here is to make this term, this denominator, into this denominator. And the strategy is, what do I have to do to that 6 to make it a 48? And the answer is multiply it by an 8. Let's see, I can put it here. If I do that, I have to do the top by 8. 8 over 8 is 1. Now, what do I have to do to this y to the 2nd to make it y to the 5th? Multiply it by y to the 3rd. So I'm going to multiply this original fraction by 1 over 1. That doesn't change its value. But the 1 will be in the form of 8y to the 3rd over 8y to the 3rd. This is 1. I'm allowed to multiply by 1. So 6 times 8 is 48. Y to the 2nd times y to the 3rd is y to the 5th. So now to get the equivalent numerator, I go 3 times 8 is 24 y to the third. Now notice, if I was canceling this out, I might get to this, but I would also cancel it a little bit more. But that's not what they're doing. They're saying you have this, they want to make this fraction with an equivalent fraction with this denominator. That's the technique. So let's do number 14. Now a good idea would be to factor that. And this would be, take out a 3, and I get 3a plus 1. Now as I look over here, how does this differ from this? Think about it for a moment. Well, it has this b there. So what do I need to do? I need to multiply this term by, I could put it out here if I want, b, and then I'd have to multiply this term by b. Remember, b over b is 1. I'm allowed to multiply anything by 1. But now my new fraction becomes b over 7a plus 3. Okay? So again, this was my original denominator. I wanted it to become this. I factored this, took out a common 3, got this, and then I looked at this and said, oh, I need a b to make it this. So I multiplied this by a b, it is now this, and my numerator becomes that. All right, let's look at 16. Again, factor this. Let's see here. I think it's 8 and 4. This is going to be a plus, and that's going to be a minus. So again, what does this denominator have that this one doesn't have? Well, I'll change back to maybe another color here. Well, this one needs x plus 4. So that's the one that this was missing. So if I multiply numerator and denominator again by 1 over 1 in the form of x plus 4 over x plus 4, I now get this for the new denominator, and this answer becomes 10 times x plus 4. Okay?